All right, so I think this is recording. Let's take a look at these two problems. They are quadratic inequalities. We know they're quadratic because the largest exponent on the variable is 2, and they're inequalities because these are not equal signs. These are less than or greater than symbols, and it might be greater than or equal to, less than or equal to, strictly less than, greater, the different combinations. So uh, let's rewrite this in standard form over here in number 9. So we've got 2x squared. I'm going to subtract 5x from each side. I'm going to subtract 3. And the arrow is pointing towards x squared. It's still pointing towards x squared. All right. So instead of trying to jump in and think about this inequality, I'm going to break it down into steps. And now the step that I need to do is just simply ignore the inequality, set this equal to 0, and solve this equation. Now, the easiest way to solve it is probably going to be factoring, although we know that sometimes you can't factor trinomials and the quadratic formula will always work. But I suspect that we can factor this. So the negative 5x is at the bottom of my x. I take the first term times the last term and write that at the top of the x. And I think of two numbers when multiplied together give me the top value, but added together give me the bottom value, and negative 6x and positive 1x do the trick. With this leading coefficient not being 1, at least it's prime. Some people will still be able to do it in their head, but like I say, when this is different than 1, probably most of you will need some organized way to factor this, and this X method provides that. And now, if we apply the distributive property and do it in an organized way using a table, we can put the first term and the last term of our original equation along one diagonal, and the two numbers that we found in the x along the other diagonal. And so now, if we look and see what's common to each, we factor both horizontally and vertically, and the table also allows us to see when we're done, if you multiply these together, if you get the inside of the table, you know you have factored it correctly. So the 2x times 1x gives me 2x squared, and 2x times negative 3. Everything to me looks to be checking. So that return to this equation. See, I can't see what the solution set is. I can't just in my head look at this and figure out what values of x will make this 0, or it sometimes you can, but especially if the answers are fractions, it's a little bit more difficult, especially for me, depending on your mental arithmetic. And for a math teacher, for anybody, I do not have very good mental arithmetic skills. But I am organized, and I do know all the properties, and I'm able to solve all these equations because I know definitions, properties, and I go step by step. All right, so this trinomial can be factored into 2x plus 1 and times x minus 3. And right now I'm just solving this solving this equation, and I'll have to return to that inequality in just a minute. So 2x plus 1 has to represent 0, or x minus 3 represents 0. So here's a two-step equation: subtract 1 and divide by 2. And here, just one step, add 3. And now I have these two solutions. Now I need a little bit more room, so I'm going to shrink this up. This software is kind of neat that we can do that. And my software at home is a little different than at school, and it's taken me a while to get used to this program here at home. But I like it. All right, so let's draw a number line and put our critical points. That's what these are referred to. Critical points or boundary points. A negative 1/2. And I don't have to be super detailed. The negative numbers are to the left of positive numbers. So if this is negative 1/2, then somewhere over here to the right on this number line, you'll find the number positive 3. Now, I need to make a decision right now as to whether to include these critical points in my solution set. Do I leave these as hollow points, or do I come in and shade them and make them solid? Well, the decision on doing that, I look to this inequality. If it contains an equal sign, if this is underlined, then I would make both of these solid. But see, this is a strict inequality. Let's look at here where I've got it in standard form. This is strictly less than 0, so I'm going to leave both of these hollow. I look at this 2x squared minus 5x minus 3. 2 is positive, so I think of this as a parabola that's opening upward. Okay, and I want values of x that will produce arithmetic that will give me a y-coordinate that is negative. So I want to be between these two. I want to pick values of x that are between negative 1/2 and positive 3, because if I do that, then I guarantee you the result will be negative because I'm below the x-axis. All right, and you can, it's probably a wise idea to pick a test point in there just to kind of test yourself and see whether this should be shaded or not shaded. 0 is very easy to do arithmetic on. 0 is between negative 1/2 and positive 3. If I plug in 0 into here, these first two terms are 0. And is it true that negative 3 is strictly less than 0? Well, yes, negative 3, negative numbers are less than 0. So this, if I haven't done an error in my factoring, I have my solution now. I want to write that in interval notation. So I want to exclude these endpoints. So I use parentheses, not brackets. It's always a smaller number, comma, a larger number. So negative 1/2, comma, 3. That's my solution set. And like I say, I exclude those endpoints. Let's come over and take a look at this number 10. Let's get this in standard form. We've got 6x squared. I'm going to move these other two terms to the other side. I'm going to subtract 5x from each side. I'm going to subtract 6 from each side. And I have this 6x squared minus 5x minus 6 is greater than or equal to 0. But just like before, I'm interested in an equation. I'm interested in the x-intercepts for this parabola that I want to find. So I'd set 6x squared minus 5x minus 6 equal to 0. The x method is going to help me in factoring this, because now all of a sudden the leading coefficient is different than 1, and it's not even a prime number. 6, it could have factors of 1 and 6 or 2 and 3. So the x method gives me an organized way to apply the distributive property, and I'll be able to factor this hopefully pretty easily. So this middle term is negative 5x, so I put that at the bottom of the x. I multiply the first term times the last term, get negative 36x squared. And I look for two numbers that would multiply together, give me the top value, but added give me the bottom. Negative 9x and positive 4x, I think, do the trick, because negative 9 times a positive 4 is negative 36. But when I add these together, I get negative 5. So now let's be organized with this information and put it in the form of a table. The first term and the last term go along one diagonal. That's from my original equation. And these two values that I found using my x method go along the other diagonal. And now I look and see, well, both of these are negative, and they're both negative 3 divides both of these. These are both even. If I look here, these are both even and have an x. 3 divides both of these, and so does x. So 2x times 3x is 6x squared. 2x times 2 is 4x. 3x times negative 3 is negative 9x, and negative 3 times a positive 2 is clearly negative 6. So we have our we don't have any errors in our table. That the outside entries from our table allow us to write this as a product of two binomials. That we have 3x plus 2. That's the across the top, and here on the side 2x minus 3, and that product equals 0. So that means that if this product is 0, it has to be true that one of these factors is 0. And so to solve this equation in 2 steps, we subtract 2 and then divide by 3. And over here we add 3 and then divide by 2. I need to shrink this up to give myself some more room to finish the problem. to finish the problem. All right, so let's draw this information on a number line. Don't be afraid of the fraction. It's a negative number, and negative numbers are to the left of positive numbers. So I know that I have these as my two critical points. All right. Now, the question is to shade or not to shade, to leave these hollow or to shade them in. And we answer that by looking back at the original inequality, and it's greater than or equal to. You see it's underlined, so I know that I'm going to include these endpoints in my solution set. In our previous problem, it was not underlined. It was not less than or equal to. It was strictly less than. And you can see that our boundary points were hollow there. So now I think about what the graph looks like. Well, 6 is positive, so hey, this is a parabola that opens upward. And I want values, if you plug in x, I want this arithmetic to result in 0 or positive, meaning that I want to be above the x-axis. So we see that if you plug in values that are to the left of negative 2/3 or bigger than 3/2, then I guarantee you that arithmetic is going to result in a positive number. If you plug in something like a 0, I know it's going to be negative. If x is 0, you've got -6. Well, -6 is not greater than or equal to 0. So 0 should not be in my solution set, and it's not. So I have confidence that I've done this correctly. Let's write our answer using interval notation. The left arrow is shaded, so that's a negative infinity, all the way up to -2/3. Since I'm including the endpoints, I need a bracket there. Since there's a jump in the graph, I need a union because I need to be in this interval or in this interval, and that union is the mathematical symbol for the word or. All right, and now the second interval, 3/2, comma, infinity. And remember, there's never a bracket at negative infinity or positive infinity because those aren't actual numbers. There is no largest number. There is no smallest number. Negative infinity and positive infinity are just kind of abstract ideas. All right, so hey, I hope that helps. Don't be afraid to ask questions. I will talk to you later. Bye.